All right, guys, so we finished problem 28 yesterday, yes? So we're going to start with 29 through 34. These are the last set of problems on the review sheet before we finish up. The first thing I would do with any of these here, especially if it says solving, is going to be to graph it. Now, looking at this problem here, how many solutions should this polynomial have? 5. How many would be nice to find by graphing?
4, 5.
I mean, it'd be nice because we need at least 3 because we need 2 less than the degree. Because if I find 3 solutions, we can use synthetic division to take it from a degree 5 down to a 4, from a 4 to a 3, from a 3 to a 2, and then we can use the quadratic formula from there. However, it'd be really nice if he gave us 5 because then we'd be done. So the first thing I would do is get the graphing calculator out, hit y equals, and type it in. So we'd have x to the 5th. Make sure minus 20x to the 3rd plus 20x squared minus 21x plus 20. And once we get it typed in, we can hit graph. And we do see that it intersects the graph x-axis at 3 points. And if we want to see the exact values, we can go second graph.
Wait, did you say second?
Mm-hmm. So we have -5, +1, and 4. At those x values, the y value is 0. -5, 1, and 4. So we did find 3 values. We need 2 more. Because the y value is, because we're trying to see what value of x is going to make this function equal 0. Now for synthetic division, to get it down to a quadratic, we would have 1 for x to the 5th, 0 for x to the 4th, -20 for x to the 3rd, 20 for x squared, -21 for x, and 20 for our constant term, and we'll bring down the 1. Which one of these 3 values do we want to use first? Because we have 1, -5, or 4, so we can do 1 first. And we'll go through and do synthetic division with 1. So we do 1 times 1, which is 1. 0 plus 1 is 1. 1 times 1 is 1. -20 plus 1 is -19. 1 times -19 is -19. 20 plus -19 is 1. 1 times 1 is -21 plus 1 is -20. 1 times -20 is -20, and 20 plus -20 is 0. Yes. So we have a choice between -5 and 4. Which one do we want to use next? Or 4. We can do 4 next. 4 times 1 is 4. 4 plus 1 is 5. 4 times 5 is 20. -19 plus 20 is 1. 4 times 1 is 4. 1 plus 4 is. And 4 times 5 is 20. There's -20 plus 20 is. Well, the only solution we have left to use is -5. We're going to do it one more time. -5 times 1 is -5. And 5 plus -5 is 0. -5 times 0 is 0. 1 plus 0 is 1. -5 times 1 is -5. And 5 plus -5 is 0. Do we have any solutions left? Well, we can go back and put the variables in. So this here would be our remainder. Our 1 would be our term without x. Our 0 would be our term with x. And our 1 would be our term with. So what we have left is x squared plus 1 is equal to 0. Now this is kind of nice because we don't have a middle term. We can use the square root method. So we can subtract 1 from both sides, telling us x squared is equal to -1. And then we can square root both sides, telling us x is equal to plus or minus. Because I, by definition, is the square root of -1. So we have I, 1, 4, and -5. And those are our solutions. Questions on this here? Are you ready for the next one? So if we look at the next one, this one here, we have x to the 4th minus 6x cubed plus 7x squared plus 6x minus 8. So let's go on and graph it. Y equals. So we have x to the 4th minus 6x to the 3rd plus squared x minus 8. X to the 3rd squared and hit graph. So we have this here, yes? So if we go second degree, so we have -1, 1, 2, and 4, yes? We needed 4, and how many do we have? Okay.
Because I'm not getting that.
Yep. We have 4 solutions. We needed 4, so we're done. Questions on this here? We good with this here? We ready for the next one? So if we look at the next one, x cubed minus 11x squared plus 41x minus 51. So let's go on and graph it. X to the 3rd minus 11x squared plus 41x minus 51. Graph. How many times does it cross the x-axis? Once. And if we look at the table, our solution, one of the solutions is 3. Now that is helpful because now we can take it from a degree 3 down to a degree 2 and we can solve from there. For synthetic division, we'll have 1 for x to the 3rd, -11 for x squared, 41 for x, and -51. So we have 1. We can do 3 times 1, which is 3. -11 plus 3 is -8. 3 times -8 is -24. 41 plus 24 is 17. Does anybody know what 3 times 17 is? Well, what should it be? Because we know this should be. It is sometimes good to just check it in the calculator. We know it should be 0. So we get this here. Now it tells us this is our remainder. 17 is our term without x. 8 is our term with x. And 1 is our term with x squared. So what we have left is x squared minus 8x plus 17 is equal to 0. And again, we can use the quadratic formula. With our a, b, and c. Now the first thing we have is negative b. Well, so that'd be negative 8, which is just 8. Plus or minus the square root of negative 8 squared minus 4 times a. Well, a is 1 times c, which is 17. All over 2 times 1, which is just the same as saying 2. Questions on this so far? Now we can type everything inside the radical into the calculator. Doesn't matter which one we use. We can say negative 8 squared minus 4 times 1 times 17, which gives us negative 4. So what goes inside the radical is negative 4. Now looking at this here, we can take the negative out as, which leaves us with the square root of 4. And what's the square root of 4? So we have 8 plus 2i divided by 2. 8 plus or minus 2i divided by 2. Are both numbers in the numerator divisible by 2? So we can divide them by 2. 8 divided by 2 is plus or minus. 2i divided by 2 is just going to be, so we have these here, comma, 3. And that's it. Questions on this here? All right. Well, we can look at the next one. We can graph it. We can say 9x to the 5th minus 27x to the 3rd and hit graph. So we do have a few places where it crosses, yes? It does cross at 0. Second table. So we have 2 other numbers and 0, yes? So we know one of the solutions for this is -1, the solution saying y is 18. Yeah. Now, we can use 0 as a part of our synthetic division. Now we would have 9 for the 5th, 0 for the 4th, negative 27 for the 3rd, 0 for squared, 0 for m, and 0. Well, 0 times 9 is 0 plus 0 is 0. 0 times 0 is negative 27 times 0 is negative 27 times 0 is 0. And we have 0, 0, 0, 0, 0. Yes? What do you think is another solution we can try? Zero times 9 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 27 plus 0 is negative 27. Negative 27 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. And 0 plus 0 is 0. That just sounds like a whole mess of zeros. Oh, now we're down to a cubic. We need one more solution. 0 times 9 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 27 plus 0 is, and 0 times negative 27 is So we have m equals 0, 1, 2, 3 times. So that leaves us with 2 solutions left, yes? This here is our remainder. Negative 27 is the term without x. 0 is the term with x, and 9 is the term with x squared. So what we're saying is we have 9x squared minus 27 is equal to 0. Yes. Because we don't have a middle term, we don't have to use the quadratic formula. We can just add it to both sides, telling us 9x squared is equal to 27. Then what can we do? Almost. Divide by 9. We want to get it by itself first. And what that'll tell us is that x squared is equal to 3. Now what can we do? I like that color. Square root both sides. Almost. Plus or minus square root of 3. So, well, m is equal to 0, 0, 0, comma, plus or minus square root of 3. And those are our solutions. Questions on this here? I want to look back at this one here. Where's all that? Is there a greatest common factor between these two? 9 will go into both, yes? How about a variable? M to the third is in common with both terms, yes? And if I factor that out of 9m to the fifth, I'm left with m squared. If I divide 27 by 9, I'm left with, here I've got 3 things multiplied together to equal 0, so we have m to the third is equal to 0, and I also have m squared minus 3 is, well, here we can, m squared is equal to, m is equal to plus or minus 3. Here we're really saying that we have m multiplied by itself 3 times, which is 0, yes? Which is just saying m is equal to 0, m is equal to 0, and m is equal to, that's it. Questions on this here? We have 2 left. So again, first thing I would do is graph it. How many solutions would we like to see? We'd like to see 3. How many do we need at least? 1. So let's look at this here. 3x to the third plus x squared. Graph. Well, we have 2 for sure, and we can go second graph. Negative 4 and 3, yes? Is our other solution going to be complex? Well, we have an I for our other term. Because if it's complex, how many do we need to do? We need 2, yes? Because I has to come in positive and negative version. Will it be irrational? Will we have a square root? No, because those also have to come in pairs, yes? Which means the other solution has to be rational. We have to have a rational number. Now, negative 4 and 3 are our 2 solutions. Now we can set up synthetic division. 3 for x to the third, 1 for x squared, negative 38 for x, and 24. Which one do we want to use first? Negative 4 or 3? It doesn't matter which. You can do either one. So we'll do 3 for this here. 3 times 3 is 9. 9 plus 1 is 3 times 10 is negative 38 plus 30 is negative 8. And 3 times negative 8 is negative, which gives us 0. So we have a quadratic, yes? At this point, we could use the quadratic formula and solve from there, yes? We have one more solution. because it's better to go on and use the other solution, because here, if we do it again, well, we're taking it from a quadratic, a degree 2, down to a degree 1s are easier to solve. Negative 4 times 3 is negative 12. 10 plus negative 12 is negative 2. Negative 4 times negative 2 is positive 8, which is 0. This is our remainder. Negative 2 is our term without x, and 3 is our term with x. So we have 3x. So even though it didn't give us all three solutions outright, it got us to something that was easy to solve, and we went from there. Any questions on this here? Are you ready for the last one? Let's go on and type it in the graphing calculator to start with. 4x to the third minus 60. Graph. So we do have three places that it crosses, yes? So we have 4. And I mean, we could do rational zeros and try to guess at what those are. But we know one for sure is 4. So we can set it up. We'll have 4 inside the cubbyhole. 4 for x to the third, 0 for x squared, negative 49, and negative 60. 4 times 4 is 16. 0 plus 16 is 16. 4 times 16 is 64. Negative 49 plus 64 is 15. 4 times 15 is 60, which does indeed give us a remainder of 0. This is our remainder, our term without x, our term with x, and our term with x squared. At this point here, we do need to solve this quadratic because we didn't have any other solutions. So we have our negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, negative b is going to be negative 16 plus or minus the square root of 16 squared minus 4 times a, which is 4, times c, which is 15, all over 2 times a. So 2 times 4, which is 8. Any questions on how we got to this point here? Are you good with this here so far? So we're saying x is equal to negative 16 plus or minus. So we'll see what the square root of this is. So we can pull up the calculator and say 16 squared minus 4 times 4 times 15. And it gives us 16. Well, we're going to end up putting that in the square root, yes? Which is just going to end up being 4. So we'll say we have the square root of 16, which is really just telling us that we have negative 16 plus or minus 4 all over 8, yes? Do we have any radicals left? Do we have any terms with I? So that means we can actually simplify this. So we'll have 16 plus 4 over 8. and negative 16 minus 4 all over 8. Both of these are going to have a solution. Now at this point here, I would grab the calculator. Fraction, negative 16 plus 4 over 8, and hit enter. Negative 3/2. And we've gone over how to highlight, or we can hit up twice, highlight it, hit enter. Because what's the main difference between the two? It's now minus, yes? So the other one is? Yes? Mm-hmm. Possibly. So here x is equal to 4 comma negative 3/2 comma negative 5/2. And that's it. Questions on this here? Question on any of this so far? Well, y'all's test is tomorrow, so try to get all those assignments turned in by the end of the day Friday.